Hi fans, in today's class we're going to be solving the third question we are given as a take home in our previous lesson on equations under modular arithmetic. We solved the first two major questions in our previous set of lessons. We solved the first and the second question, and this is the third question we're about to do justice to today. So if you're just seeing this very question for the very first time, I want to give it a try. I advise you could pause this video quickly and make an attempt. So for those that have made an attempt already, let's see how many solve this question right. So we are asked to find the value of p in 5p minus 4 equals to 3 in modulo 6. Now this is a linear equation. As you can see, it's very, very simple. It's a linear equation. So how do we solve this? And don't forget, you're operating with modulo 6. So you have to get the value of p. So we're going to solve this like the normal way we solve our linear equation. So what I'm going to do first is just 5p. We send the minus 4 to the other side. 3 plus 4 in modulo 6. So what I do next is 5p equals to 7 in modulo 6. Now when you look at this, 5p equals to 7 modulo 6. The 7 you're talking about should not even be modulo 6. It's way bigger than the modulo 6 you're talking about there. So we could reduce the 7 to a 1 modulo 6. Very simple to do this. 6 and 7 is 1 modulo 1. So it's more or less like saying 5p equals to 1. So let's say 5p is equals to 1 in modulo 6. Don't forget that when we talk about modulo 6, the set of numbers that should make up modulo 6 should be between 0 to 5. 0, 1, 2, 3, 4, and 5. If you're talking about modulo 6, the numbers that make up modulo 6 should not even be up to 6, talking about being modulo 6. So you have 5 equal to 1, and it's very simple for us to solve this. We're going to create a table getting the multiples of 6. So we have 6 times 0, 0, 6 times 1, 6, 6 times 2 is 12, 6 times 3, 18, 6 times 4 is 24. So we add each of these multiples to 1, then we end up getting an equation we're going to solve for the value of p. So this is 0, 0 plus 1 is 1, 5 equal to 1. Variable size for 5, you know what that is. So we can use this. So let's try 6, 6 plus 1 is 7, 5 equal to 7. 5 to 7 is 1 and the remainder 2 over 5, that's 1.4. Let's try 12, 12 plus 1, 13, 5 and 13, 2.6. 18 plus 1, 19. 24 plus 1, 25. I think that's beautiful. So 5p equals to 25 variable size with the coefficient of p. So p is 5. Don't forget, whatever value you're going to get for p should not be up to the modulo we're talking about. So p is 5, and that is beautiful. That is the value of p. So let's try that. Let's see if you're going to get this result. 5 times 5 is 25. 25 minus 4 is 21. 6 and 21 will give us 3, 18. Remember 3.